Hello there guys, I'm back after a long break. So I don't even remember now where we left. Probably somewhere. Yep, we created the gravity, which is awful. And yes, this is where we left. So now in this episode, I'm going to improve our gravity and make it a exponential function, so it may look like normal gravity. Also in this episode I'm going to make jump. So when you press your up key on your keyboard, your bird will jump. So this video is going to be a straightforward video, nothing special. So let's continue with our code. First I will explain the logic, then I will write the code behind it. Okay. So currently what problem we are facing is we have take an example, we have some variable x, and what it does, take x as gravity. So what it does, it every time we call x, every time our instruction pointer iterate over the x function, which is our gravity function, of course, uh, this value increased by some, let's say some number, what we and we have used like 0.5 here. So this x become x plus 0.5. So if we try to graph this function, what we will see, we will have, for example, if number of times we are calling it, uh, this is number of times we are calling it this, and this is how much of our value is increasing. So it will make us somewhat a linear line. So this is a linear function and we do not want that, because you can see the gravity acts in a different way. For example, it is started small, then over the course of time it increase, and it becomes very large very quickly. So when you see an object falling, it is falling first, it is falling at very slow pace, then it picks up speed, and then it becomes extremely fast. So if we try to draw a function like that, I will draw side by side. So what that function will do is take that number, for example over x, and then multiply it by some number, and this will update it. So for example, we can use any number, any digit, depending on our condition, how fast we want to make it. So if I try to draw this function now, what this will happen, you see, first it is starting small in comparison. I mean, it is still larger than this this point at start, but in comparison to its later stages, it is small. So what will happen, as the time passes, this function is going to increase increase increase, and it skyrockets. So this is an exponential function, and this is what we want. We want our gravity to start slowly, then slowly picks up speed, and then picks up more speed, and then become extremely fast. So this is the difference between the two. If I try to draw this here, so a linear function would be somewhere here. So as you can see, this start deviating from somewhere here, which is exactly what we want. So now all we have to do is implement this function, and we will use our SDL get tick function for getting time and stuff. If you don't know what SDL get ticks is, I already explained in my previous videos. Also I done the thorough video in which I implement I guess FPS version, like how to implement FPS, I don't remember correctly. So that's pretty much it. And also we are going to use what's called SDL SDL uh, get key. So we will get our key, for example, for taking input from our up arrow key, our up arrow key. If we want to press this our bird will jump. So we will use SDL key function, and in which we will our in which our in which we will apply all the changes and things, and apply our functions which will we make. So now let's try to implement this function. We already have implemented this function, but we do not want that because this looks stupid. Come on. This is what we want, so we will try to implement it. But from experience, what I have found that exponential function are a bit too fast for like this Flappy Bird game. So I will try to make something like in between. It's not exponential, but it's not linear also. So it's somewhere in between an exponential function and a linear function. Okay, let's try. Let's see and observe how to implement this. So we move to our code, and so first I implement two accelerators, which will be used as you can say multiplier for this function. So I will make accelerator 1. This is just name of my variables. You can use anything. Also, there is no rule to making any gravity or jump. Have you just have to get experience from making games in the past, and you will learn how you can make make out your thing and make it work for different games. So it's not fixed, it is definitely very flexible. You can use this my exact model and can implement it in many different games just by tweaking up the values. But for most part, I think you should not copy, you should make one of your own, because it isn't something you should copy. So I will make a boolean in jump. Oh, I forgot to mention something, I guess. So here's a tricky part. If we press our key, we should have a delay between two key presses, because if we, for example, if I press my key, it will not register my key once. It will register my key, like if I press for a microsecond, it will register it for like 6 or 7 times. So which is not ideal, because we want our character to our jump only one time, and even though we are pressing for a very little amount of time, our computer registers it as multiple key inputs. As you can see, when you press up key or down key on a page, it scrolls not one line but several lines. So simply you can think of it that way. And what will happen if I, for example, this is my bird, if I press key, this will skyrocket and go out of the bound, because it is running that our jump function several times, while it should only be pressed only once. So what we have to do, we have to measure something, like we should have a measure in which, by which we can tell if our bird is in jump state or not. So we will create a state function, a state variable, and our state function, which will be a getter. It will determine that our bird is in our jump state or it is out of jump state. It is out of jump state, that means we can jump again, otherwise we cannot. Otherwise we have to wait for a certain amount of time, certain microsecond, like should be good value should be 180 microseconds or something. It is equivalent to 0.18 seconds, and I think that should be good enough. So that's explanation for our jump state and all that stuff. Now I will try to implement it, and I wrote it wrong here. So next would be our jump height variable. Also this varies according to vary in different games. From experience I find that this works fine for me because I already have created this game once. That's why. Now we will create a last jump. This will have our time from last jump, and we will use it to calculate our delta time, which is the difference between two times. So it will tell us that if the time interval has been completed, so we can jump, or if it hasn't been completed, the time difference that is 180 microsecond, so that means I cannot jump. This will determine, and I will create here three functions. I will name them void. First will be a getter, get jump. This will get our jump time, and this will use SDL getting functions. Okay, so next will be um, void jump function. This will get our this will check our we can jump or not. I mean the time has been elapsed or not. This will check that. And then we have a simple getter for our game state or our jump state. This is simply return us if jump state is true or false. This is nothing else. Very simple. And now we will implement it here. We already have a gravity, so we will implement our jump in our gravity, but how we do it totally depends on you. I have a very different approach than usual. You can do it on your own, make something crazy. So I have feather player, and I will get jump time. And what this function will do is our take our jump timer and take our time by using SDL get ticks. SDL get ticks function, and it will give us the time of our jump. Okay. So by this we can check how much time has been passed since our jump is taken. Now we will do a simple getter here. Simple getter for our bool player jump state and it will simply return our in jump variable. So if it is in jumping state, our jump variable is true, otherwise it is false. Whatever the condition, it will simply return. Now what we will do here is we will make our jump function, which will check if our jump has been our time has been completed, our time of jump has been completed or not. Otherwise it will continue our gravity function. Okay, so if jump is taken, then our jump is true. If not, then whatever the condition will be, for example, it will stay false if it was false, otherwise it will be true if the time has been elapsed. So problem is this all is my logic, so if you want to try this, you can try this, but I don't recommend it because you should be able to make your own logic, because no two brain works the same way. So there is no point of me arguing that this is how you should do it. You can do any way you want, but the main idea and result should be the same. So I will reset all the values. This accelerator variables are nothing but just a carrier for some values. So what will they do? They will add into our gravity. So our gravity will increase by this accelerator numbers, whatever the value we put in our accelerators. Okay, so we can change the value of our gravity. For example, like if we want lower gravity, we can change our accelerator and our gravity will be lowered, and we can increase it accordingly. So yep, and this will mean our when our time has been exceeded, that means our jump is true. Not that means we can jump again, and also we will have to update our last jump because time has been elapsed. So our jump timer should update our last jump because we just made our last jump. And here else, if this is not the case, then continue with your gravity function, continue to pull down the bird. So this was our jump function. Now we will have to implement these changes. Now we have to use this jump function and every other function which we like, jump state function, and yeah, just jump state function. We will use them in our gravity function to update the values. So first of all, I will write if my jump state is true. Wow, what I'm writing. If my jump state is true, that means I can that means I will have to apply a jump with my gravity. That means so basically what jump is addition of something. You can imagine this bird, what forces are being applied to it right now at this moment. First, it is gravity, which is constantly increasing. So this is going down faster, but what jump is, basically we are going at this point, whenever we press our button, we are going to what's called we are going to add some value in we are going to add negative values, so such that our bird is going to jump in up direction, because as you know, if we subtract our y coordinate, our bird will go up. So if we subtract or if we add negative values to our bird's y coordinate, our bird will go up. This is what's the foundation of our all the game. Basically, all we are doing is adding negative values, so it will move in y coordinate in the upper direction. Okay, so that's basically all we are doing. We are adding negative values there. So how much we want to accelerate our object is depend on the values of these variables. So if I put 0.035, these values work for me for this game only. You can mess around with them and check how they work. You should have idea of how things work in your game, so you can change them if you want. However, these works really nicely for me. Now this is our jump height. This is a negative value, so we are going to our jump height plus gravity. What this is going to do is, our gravity is a positive value, so our jump height is a negative value. Now we will continue doing this until our jump height is our jump height. After that, our jump height will have no effect on our gravity, and our function will work as normal, like gravity will continue to pull as normal. So what will we do? We'll update our y path is equals to y path plus our gravity. Remember, this is we already have remember, this is gravity. Now we will add acceleration 1 plus acceleration 2, and what do we have? We have jump height, which is a negative value. Also here we have our set destination function. This will update all the changes we just made. So it is 25 y path 28 38, and if our jump height is greater than 0, that means our negative value now has become a positive value due to increment. That means it has been normalized, and now we do not need to use it. What I do? Oh, I made it. In jump false, we'll say our bird is not in jump state anymore, and we will reset our jump height, which was initialized as -6. Then again, you can use any number here depending on your game's requirement, but these numbers work fine for me, so I will stick with it. And if our bird is not in jump state, then in else part, what will this will happen? This is simply our gravity, but we have to make it exponential, remember. So what we will do, we will copy paste all the above, but simply we will not add jump height. So copy here, paste there, we will remove this line, and I think this is good. So this is our normal gravity function, how it looks like without our jump, involvement of our jump, and this is when our jump is involved. So that should be it. Now we have to take input. Remember, we cannot apply it without taking input. So what I will do is go to our game loop, and where we have taken an input for our mouse, for example, where we are quitting our game, I will do here simply if, and I will write event 1 dot type equals to SDL key down event. So what this will track, if any key is pressed, any key on the keyboard, this will jump into this if condition. Okay, so now after this we have to specify what key is pressed, so it may not run on any key, only run on up key. So I will make another if, and in that if I will write event dot key sm dot sym is equals to, oh god, sk this is SDL key, and now as you can see, these all are keys you can use. For example, you can use B, C, caps lock. I don't know if computer exists. What kind of key is this? Like seriously. It E F F11 keys. So you can basically write anything here. I am going to write up key. You can use any key. You can use volume down key if you are using it for a mobile. And now in this, if our up key is pressed, but remember what we have here is, if our jump state is false, then do not jump. If our jump state is true, only then jump. So what I will do, I will simply, if p dot jump state, our jump state is false, then jump. Otherwise simply call gravity, like simply implement gravity on the bird and do nothing else. Also we have to take time here, so what we'll do, p dot get jump time. Yeah, and this should work. Now if I hit the key and pray it may not crash, so it should work. And it is working, as you can see. Our gravity is smooth, as well as our jump, as well as our bird, which is great. So yep, this is fine, and this looks great. So that was all for this our jump function and blah 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 whatnot. And in the next video I think I should make polls and all this stuff. So stay tuned, and thank you for watching. If you learned something, bye.